Hello everyone. So let's go over this activity now that you walked through it. How much air is in your lungs? Alright, so you watched the video, you did the breathing activity, right? And obviously you for sure read the directions here on the little story of the situation. So I'm going to go straight to the work. How many seconds in each inhale, breathe in? How many seconds in each exhale, breathe out? So when you watch the timing on the video, you should have noticed that it takes 6 seconds to breathe in and 6 seconds to breathe out. So it's the same length. All right, what is the maximum volume of air in your lungs? What is the minimum volume of air in your lungs? Okay, so we are told that the maximum lung capacity is 6 liters, right? So when I breathe in for 6 seconds and I fill my lungs completely, the maximum volume is 6 liters. And again, that's for an average adult, right? Obviously, we're all going to have some differences in that. And then the minimum volume of air, well, it's not going to be zero, right? We never have zero in our lungs. It says that when we exhale, we are going to exhale about 80% of the air. We're going to release about 80. So we're keeping 20% of that air within our lungs at all time. So the minimum volume will be, well, it will be 20% of that 6 liter, right? Because we're exhaling 80% of it, so we'll have 20% left. So 20% will be 0.2, and then we multiply 6 by that to get how many we have left, and it will be 1.2 liters. So that's the minimum we would have. Now we have to sketch a graph of the volume of air in your lung during the first 30 seconds of the breathing exercise. And then what do we notice? So the first 30 seconds, notice how the scale and everything is ready for us to go, right? So this is our axis time in seconds, so from 0 to 30. And then this will be the volume of air, and the maximum we can have is 6 liters, right? So it's all set up and ready for us to go. So at time 0, I have everything exhaled and I'm about ready to inhale. At time 0, I will not have 0 in my lungs, right? We talked about how the minimum we would have is 1.2. So we're going to put that 1.2 somewhere. So 1.2 is about there. And then the maximum I can have, and this is in seconds, right? And it takes me 6 seconds, 6 seconds to inhale. So after 6 seconds, so 6 seconds is here, I will reach the maximum that I will have in my lungs. So after 6 seconds, I will be at 6 liters, so right up here. And then I'm going to start exhaling again, and 6 seconds after that, so at 12 again, I'm not at 0, I'm at 1.2 about, and then what happens after that? Well, I'm inhaling again, right? So 6 seconds later, I'm at the maximum again, and then out, exhale, so 6 seconds later will be 24, where are you? Right there, and that will be 1.2 again, and then again I'm going to inhale, and so 30 seconds it will be back at the maximum. So this will be between 0 and 30, the first 30 seconds. And obviously this is not going to be a straight line segment, right? It's going to have a little bit of a curve to it, right? So we're going to not make those straight, but a little bit of a curve to it. Here we go. All right, that will be for the for the first 30 seconds, right, of the breathing exercise. What do you notice? So I hope that you notice that the graph actually repeats itself, right? It's the same pattern repeated over and over and over. So I hope you have to notice that. So the graph repeats itself. There are several other things we could be talking about, right? We could be talking about how the maximum of 6 liters is reached every, so let's talk about that. So at 6 seconds I'm at the max, I exhale and I inhale, so at 18 seconds I'm at the max again. So how often am I reaching the max? Well, that would be every 6 seconds, right? From 6 to 18, and then again from 18 to 30. So that would, every time, that would be 12 seconds, right? So maximum 6 liters is reached every 12 seconds. And so would the minimum, right? The minimum, and then 12 seconds later, and 12 seconds later, etc. What I just described here, from one maximum to the next, is what we call one period of the graph. Now, the one period of the graph doesn't have to be from that point to that point, but this is makes it easy for me to spot and to calculate, right? I can count from here to here, from the minimum to the minimum. That's also one period of the graph, right? That would be 12. That would be 12. So you can really measure the period of a graph from any 2 points, but the minimum points, the maximum points, those make it nice and easy to spot them, right? Okay, so how long does it take to go through one full breathing cycle? So to go through one full breathing cycle, it takes 12 full seconds, right? 6 in, 6 out. And that is the time between either two maximum or, and I shouldn't say maximum, the plural of maximum will be maxima, or two minima. Okay? How many full breathing cycles can you go through in 2 minutes? Well, how would we know that? If we know that one full breathing cycle in, out is 12 seconds, how many of those full cycles could I put in 2 minutes? Well, to know, we will divide, right? But those are not the same units. I have 2 minutes divided by one cycle, which is 12 seconds. And if you have any science at all, you would know that we can't do that, right? We can't divide that. Those are not the same units. So we're going to rewrite the 2 minutes in seconds so that they match, right? So that will be the same. So we have 60 seconds in 1 minute, so 2 minutes will have 120 seconds divided by the 12 seconds of a cycle, and now we have the same units. So now we can divide those values. So 120 divided by 12, that would give me 10 seconds. So, sorry, that shouldn't be seconds. Whoa. Just made a mistake here. Seconds and seconds, we cancel them, right? Those are gone. So what did we really find? Those are not 10 seconds, right? It's 10 cycles. So 10 full cycles within 2 minutes. All right. Estimate the volume. Let me change my camera a bit. Estimate the volume of air in someone's lung 93 seconds after starting the breathing exercise. Okay, so that's going to be a little tricky here, but 93 seconds after we started the breathing exercise, how many full cycles did we have? How many times did we in, and out 12 seconds. Well, this is already in seconds, right? So we're just going to divide. So we're going to say 93 seconds divided by 1 full cycle is 12. And that's going to tell us how many cycles we have, right? So when you do that in your calculator, you should get 7.75 cycles. So if they start at a minimum, like we did here, if we start at a minimum, they're going to have 7 full cycles, right? So 7 full cycles. So if they start here, 1 full cycle will take them back to the minimum, right? So after 1 cycle, they're back at the minimum. So after 7 full cycle, it will be way down the line, way over there, if we could extend that graph. But it will still be at a minimum after 7 cycles, right? And then we have that extra 0.75. Well, 0.75 will be 3/4 of a cycle, right? So we will be 7 cycles completely. And then half a cycle will take us to a max, right? And then another quarter of that will take us somewhere halfway through that, right? Somewhere halfway through that. So we're going to be somewhere halfway between 6 and 1.2. So somewhere halfway between 6 and 1.2. So I'm going to say 6 minus 1.2, right? Is going to be 4.8. And then I'm going to divide that by, that's the distance from here to here, right? 4.8. And I want half of that. I want somewhere halfway between those two values, right? So I'm going to divide that by 2. And 4.8 divided by 2 would be 2.4. So the volume of air that I would have in the lungs would be about 2.4. Did I do that right? Oh, no, I didn't. Oh, I hope you caught that. Okay, so 2.4 would be from here, right? From 1.2 all the way to up here. I would measure 2.4, but starting from here, 2.4 up from that minimum point of 1.2. So really, to know how much I would have, I would take 2.4 plus that 1.2 that's always there, right? Because we never empty the lungs completely, and so that would be 3.6. So after 93 seconds, so let's put a sentence there, after 93 seconds of starting the breathing exercise, we would have we would have 3.6 liters in our lungs. I should say liters of air, right, of course, not water. All right. So again, what was that all about? If we start at if we do 93 seconds, we're going to divide by 12, 1 per cycle, to see how many full cycles do we have. And we're going to have 7 full cycle, and then an extra 0.75. Well, that's a quarter, 3/4, sorry, an extra 3/4 of a cycle. So where would 3/4 of a cycle be? Well, half a cycle will take me to the max, and then another quarter will take me halfway through there, right? Halfway between a minimum and a maximum. So I'm going to subtract my max and my min to see what that distance would be, and it will be 4.8. But I already, and I want halfway through, so I'm going to divide that by 2. But that will be the distance between 1.2 and 6. So I still need to add the 1.2 that I always have in my lungs, right? So that would be 3.6, and that's how we got that after 93 seconds of starting the breathing exercise, we would have 3.6 liters of air in our lungs. Okay? Now let's do some quick notes. Quick notes. So, two variables have a periodic relationship if the output values demonstrate a repeating pattern over an equal length interval. Actually, I don't even need that because it could be, it's several, right? Because it repeats constantly. So we don't even have to put the singular here. So over equal length interval. Okay? And then what else? The graph of a periodic relationship is determined by a single cycle, right? So the graph of a periodic relationship, oops, is determined by a single cycle, which we call the period. Many times we give it a letter, and in this instance, I'm going to call it the period. Let's call it the period. Let's use H. Okay, so f of x plus h, if h is my period, would be the same thing as f of x. Okay, what do I mean by that? I'm going to use the graph that we have down there to explain that. If f of x is my function and my period is h, right? I have an h horizontal distance of a period. That's like doing a horizontal translation. So I'm going to take my function f of x and I'm going to add or subtract h, which is the period, right? The distance horizontally until the cycle is complete, and I would end up at an f of x again, right? So what I mean is f of x being our y value. If I start my cycle here, for example, and I do one full period, and in this case the full period was 18, right? So you do one full period, so from here to here. So if this is my first f of x and I add 6 to that, I'm going to end up at the same y values and where I started. I'm going to end up at a y value of 1. And remember, f of x, those are your y values, right? That's what that means. And this will be true for any number. Like I could pick this number, for example, right here. This has a y value of 4. And then when I complete one full cycle, now remember we said one full cycle for this example would be 6, right? 12, from 6 to 18, 12. So I'm going to start here, and I'm going to go 12 in the horizontal direction. So from 3 plus 12 will take me to 15. That will be right there, and I will end up at the same y value, which is 4. F of x is one y value. If I add or subtract a period to it, I would end up at that same y value there when I started. That's what that tells you. Okay, now a few more things I wanted to show you. For example, a period doesn't just mean that we're going to have some kind of repeating look, because when you're looking at that, It sure looks like it repeats, right? But it doesn't, because even though the waves kind of repeat in the same width interval, they're not, the minimums are not the same minimums, right? See, this minimum is here, this one is here, this max is here, this max is here. Those are not the same y values or for the min and the max, right? So this is not a periodic, not periodic. Okay, and then the other thing, this one, however, is periodic. And well, you're going to say, well, this maximum is not the same as this one, and you will be right. But if I'm looking at my pattern, so I'm going to start from 0, for example. It's kind of always nice and easy to start there also. And if no, let's not start at 0. I'm going to actually start at this minimum point. Let's start here. I'm going to go from that minimum to this minimum, and look what's happening. I'm going up, and then down, down, down. But then I'm going up again, but not to that same point. That will mean my cycle is not finished. So I'm going to keep going. And I'm going to come back down, and that will be one full cycle from here to here. Because from here to here, it will then repeat exactly. So then I will take that, move it here, and I will have that exact same pattern, right? See how I'm going up 2 over 1? Look, up 2 over 1. Then I'm going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Then I'm going up 3 over 1, up 3 over 1, and so it repeats like that. So this is periodic, and what is the period? Well, from that point to this one, and then it repeats after that. So that will be, if this is a x of 1, that will be 2, 3, 4, 5, 6, 7, 8, so that's an x of 8. So from 1 to 8, the period is 7, right? We have 7 units between 8 and 1. 8 minus 1 equals 7. All right? So then we have a few things that we could use, knowing that this is going to be periodic, so this is definitely going to be a periodic function. And now that we know this is a periodic function, now we can find things about the function that we don't see on the graph, that beyond the boundaries of our graph, if we just know where they happen. So for instance, does g of x have a minimum, maximum, or neither at 15? So when x equals 15, does my g of 15 represent a minimum or a maximum? Well, I would have to look at my pattern here, at my cycle, and see where would I be at 15. Well, okay, let's look. So I'm starting at 1, and when I'm arriving at 8, I will have done one cycle of 7. Well, if I do another cycle of 7 from 8, where would I be? If I do another cycle of 7 in that direction, 8 plus 7 is 15. That's exactly the one I'm concerned about. So 8 is a minimum. One full cycle after that minimum, I should be, we just said that, right, at the same y value. After one cycle, I should be at the same y value. So I'm at the minimum. I'm adding one full cycle of 7. 8 plus 7 is 15, and therefore I'm going to be at that same y value, which is a negative 1. So the g of 15 equals negative 1, which is a minimum. All right, let's keep going. Is g of x increasing, decreasing, or neither on the interval 26 to 29? Well, okay, so we need to figure out where in the cycle will we be 26 to 29. So you can do that in your head, or you can just kind of write things down if that helps, right? So let's see. At 1, I'm at the minimum, right? So I'm going to do that on the side here. Let's see if I can kind of repeat it from here. So at 1, no, you don't see it. At 1, I'm at a minimum of -1, right? That's at 1. Okay, then I'm going up 2 over 1, so up 2 over 1, so at 2, I'm there. Then I'm going down 1 over 1, down 1 over 1, so I'll be right there. Then we said we're going to go up 3 over 1, right? So up 1, 2, 3 over 1, so I'll be here. And then I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, 3 times, right? So 1, 2, 3. And that's my 1 cycle, right? So right there, I'm going to be at 8. That's 1 cycle of 7 units. All right, I hope you're with me. So now we're repeating after that, right? So now I'm just repeating. So it went up 2 over 1. So up 2 over 1, I'm going to be here. And then down 1 over 1, down 1 over 1, I'm going to be right there. And then up 3 over 1, up 3 over 1. And then down, down, down. And I'm going to be at the end of my cycle. And earlier we said that this here should be 15. That's what we decided here. So let's check 8, 9, 10, 11, 12, 13, 14. Sure enough, it's 15, right? Okay. So I want to go all the way to 26, between 26 and 29. So I'm at 15 now. So 15 plus 1 full cycle will take me where? Well, 15 plus 1 full cycle would be 22. I'm not quite there yet. I'm far away from it though. You see that 1 full cycle would take me back down to a minimum point there at the beginning, but 26 starts 4 units from there. So 4 units from there would be 1, 2, 3, 4. So I will be at a maximum at 26, right? And then 26 to 29, that would be 3 units. So 1, 2, 3, and I will be right there at a minimum. So between 26 and 29, the function is decreasing, right? Going down from left to right. So decreasing. Okay, you can pause the video, go over it again, right? And I hope that will make sense then. Last one. What is the rate of change on the interval from -3 to -2. So I'm moving backwards, right? So right there, we're at -2, and then -3 will be 1 more. And when I'm reproducing my pattern backwards, so this is my long going up, so that will be this one right there. And after that, I'm going to go down 1, 2, 3 over 1. So 1, 2, 3 over 1. So I will keep going this way. And I want to know what is the rate of change on the interval from -3 to -2. Well, from -3 to -2, from left to right, we're going to go up 3 over 1. So here the slope on that interval is up 3 over 1, which is 3. All right, so you are now going to complete the check understanding, right? You're going to do that on your own. Then you're going to read that front page. Well, maybe not, because I want you to have the notes for your homework. So go ahead and work on your check understanding, and then your homework is attached to that assignment, so don't turn that in, okay? Just keep it, and we'll turn it in on Friday or Monday, whenever I see you next. All right, have a good day. Bye.